The problem is number 18, which is a 25 kilogram object is moving at an unknown velocity when it experiences an unbalanced force that is shown by the graph below. If the object comes to a stop at 40 seconds, what is its initial velocity? The best way to start this would be to write down what we know, which is that mass equals 25 kilograms and that time equals 40 seconds. It's also noted that this is a force versus time graph, which means that we can find impulse and change in momentum by taking the area underneath the graph. To find the area underneath this graph, because it is a triangle, we have to do base times height divided by 2. So in practice, this would be 40 times 100, which equals 4,000, divided by 2, which equals 2,000 kgms. Kg meters per second, not kgms. Now this is the total momentum. We notice the total momentum inside this equation because it starts with 0 and it changes with 2,000 kilogram meters per second all the way back to 0. So we know 2,000 kilogram meters per second is the total momentum in our equation. We also can use this to find that v will actually equal a negative number. This is because if it's a positive change momentum that brings us to 0, then v has to have an initial negative velocity. Next, we're going to use the momentum equals mass times velocity equation to find velocity. Because we have the total momentum, we can use this equation to divide by mass to get velocity. So 2,000 divided by 25 would equal 80 meters per second. But because this is negative, 80 meters per second equals negative 80 meters per second. I'll just add these units in here real quick. And that is how you solve the problem 18.